This is section 8.1, and we're going to work mainly with solving right triangles. So the first thing we want to do is understand the language. In a right triangle, you have two legs, and you have the hypotenuse, which is across from the right angle. We've talked about this before, the acronym that helps you with this information here. Sine is opposite over hypotenuse, SOH. Cosine is adjacent over hypotenuse, CAH. Tan is opposite over adjacent, tan, opposite, adjacent. And so if you can remember SOHCAHTOA, you can always remember those. And the opposite is if you look at your angle, wherever your angle is, just go directly across from it. That's your opposite piece. We might also look at this complementary angle theorem before we get to examples. Cofunctions of complementary angles are equal. So cofunctions are sine and cosine, tan and cotan, secant, cosecant. And if you have cofunctions, they're equal if you take the complementary angles. Remember, complementary angles add up to 90. So the sine of 30 has to equal the cosine of 60. Tan 40, cotan 50, secant 80, cosecant 10. So complementary angles, cofunctions. All right, now let's see what we would do if we were trying to solve this right triangle. You're given that B is 2. Now that's lowercase b, so that's the side. So that's here. And angle A, capital A, is 40 degrees. So 40 degrees. Find A, C, and angle B. So you're supposed to find all the other parts. Well, we always know in a right triangle that the other two angles besides the right angle have to add up to 90. So you can solve for angle B real quickly. So we've got angle B is 50. Then we look at what we're given. We're given 40 and we're given 2. So we've got the adjacent to 40. Well, the tan function is opposite over adjacent. So if we wrote that statement out, tan of 40 equals A over 2. So once you write that statement, then you're just going to solve for A. So multiply the 2 to the other side. So you have 2 tan 40 equals A. And then once you've got your A by itself, you can just do this in your calculator. Let me get my calculator up here. All right, so I've got my calculator, and the first thing you want to do when you're working with your angles is make sure you go to mode, and you want to be in degree mode. So I'm going to go where it says radian. I'm going to go over to degree and hit enter, and then I can second quit. So I want to just put this statement in my calculation screen, 2 tan 40, and it's in degrees. I can just close that and enter, and I get this number. And probably your question will tell you what to round to. I rounded to 2 places. Okay. Then we can do the same thing with 50. We know the opposite. We don't know the hypotenuse. Let's see. That would be, yeah, we can go there in just a second. But you could use it and do tan 50 and solve for A that way. But we did it this way. All right, now looking at 40, if we're trying to get C, we have adjacent and we have hypotenuse. Remember adjacent and hypotenuse? Right here, cosine. So you want to write a statement. Cosine of 40 is equal to 2 over C. Multiply C over here. Then you're going to have to divide by the cosine 40. So we get to this, and we'll do that on the calculator. So if we were doing that one, it would be 2 divided by cosine 40. And enter, and we get 2.61. All right, so that is what solving the right triangle is. You're using the things you are given to find all the things that you do not have. The last thing we want to do is just talk about angle of elevation, angle of depression. If a person's looking up at an object, the acute angle that's measured from the horizontal to a line of sight to the object is the angle of elevation. You're looking up. If you are looking down, here's your horizontal, you're looking down at this object, this is your angle of depression. So we may use those in some problems. Let's go get our problem set. All right, number one, and we've done this several times and it's worthwhile looking again. Find the value of each of the 6 trig functions. So you're given a is 4 and b is 3. You always have to find the c. I did that over here, used Pythagorean theorem. 3 squared plus 4 squared equals r squared. So r ends up being 5. Once you have that, sine of theta is opposite over hypotenuse, 3 over 5. Cosine is adjacent over hypotenuse, 4/5. Tan, opposite over adjacent. Once you have these 3, then you just flip them. Sine, you flip to make cosecant. Cosine, you flip to get secant. And tan, you flip to get cotan. So that one's pretty easy. You would do the same thing with number 2. The only difference is you end up with a missing piece that has a radical in it. So we did the same thing to find r, or in this case, we're not finding r, we're finding the y value down here. So now I've got my 3 pieces. Here's my theta, opposite, adjacent, hypotenuse. You do the very same thing. You just do have to do some reducing and some fixing of your radicals, but we should totally know how to do that at this point. Number 3, find the exact value of the expression, do not use a calculator. Well, here's what they want you to know. Sine and cosine are cofunctions. 51 and 39 are complementary. Those things are supposed to be equal. So if they're equal and you're subtracting them, you're going to end up with 0. So that's the strategy for that one. Number 4, now this one, sine and cosine are cofunctions. 43 and 47 are complementary. So those things are equal. If you've got something over itself, you end up with 1. It's just some strategy in thinking about it. Tan 76 minus cosine 46 over cosine 76. Okay, so what do we know here? So if we think about it, cosine 14 is equal to sine of 76. That's a true statement. Complementary cofunctions. So if we substitute this sine 76 for the cosine 14, we now have this. This sine over cosine is equal to tan. So now we have tan 76 minus tan 76. We end up with 0 again. Use the right triangle and solve. So you're given side B, you're given angle B, you're supposed to find side A and C and A. We do exactly what we did in the example at the beginning. A would be 90 minus 46, so we get 44 for that one. Then if we're going to solve for A, we have this angle, angle 46, and we're solving for A, and we have opposite. So opposite and adjacent is what we have. So tan of 46 is 4 over A. Multiply your A here, divide by tan 46, do that in the calculator, you get A is 3.86. Do some different things to find side C, but what I did in this particular one, I knew that side A was 3.86 and side B was 4. So I used Pythagorean and I said that squared plus that squared equals C squared. And I went on from there. All right, number 7, exactly the same methods. You are given 2 things, you're finding the others. So you find an angle, then you figure out which trig function you could use there. Then I used Pythagorean to get C. So I think you can follow that one. Let's look at this one. We have A is 8, angle A is 35, find B, C, and angle B. So angle B is easy, 90 minus 35. Same thing. What do we have? We have angle A and we have opposite over adjacent that we can try to find B. So we did this one, we get that, then we can find C. These are the exact same strategies. All right, number 9. For number 9, we are only given one. Do we have one angle? We only have the right angle, and we're given A is 16 and B is 3. So this is a little different. So we can find side C by doing Pythagorean. 3 squared plus 16 squared equals C squared. And we get that, take the square root, you get 16.28. Now, we're looking for an angle, so that's different than what we've been given before. The tangent of A is equal to 16 over 3. So when you go to your calculator, let me clear this, we would do second tan, because we're looking for the, we're given what tan is and we want the angle. And we'll do 16 divided by 3 and enter, and we would get 79.38. We're rounding to one place, and we get that. So if you're given what the tangent is, then you're going to do second tan and put that in. And then you can find angle B by subtracting. And we'd be good there. All right, a right triangle has a hypotenuse of length 2. So they didn't give you a picture, so we've got a length 2. If one angle is 35, find that length of each leg. Okay, so we don't know this. But sine of 35 is this side over 2. Sine 35 equals A over 2. Multiply 2, and you get that. Cosine of 35 is B over 2. So you do the same things. You just had to draw the picture. All right. Number 11, find the distance from A to C across the gorge illustrated in the figure. The distance from A to C is what? All right, so I drew it here. It's a little bit clearer than that picture that we've got. We got an angle of 25 degrees. We've got this is 140, and we are supposed to find side B. Well, the relationship between this and this is tangent. Tan of 25 is B over 140. Multiply your 140, and then you get B is 65.28. And number 12, same idea, we're finding the height of the tower. So if you'll draw it over here, it's a little bit easier to see. We have an angle here of 85.052 degrees, and we know that this leg is 70. And we're supposed to be finding this. That's our x. So the tangent of this angle is x over 70. Multiply the 70 here, do this on your calculator, and you will get your x. I think that's it for the problem. So you're going to be solving some right triangles in 8.1, and I think we've got enough to do that.